Welcome to the Micronaut podcast. The Micronaut podcast is a podcast about the Micronaut framework, which is a framework on the JVM. I am Sergio del Amo, your host, and I am lucky to be with Micronaut co-founder Graeme Rocher. How are you, Graeme?
Good, thanks. How are you, Sergio?
I'm fine. How is raining a lot where you are?
Oh, yeah. Yeah. We've had a lot of rain. The rivers are almost overflowing, and it doesn't look like it's going to stop for another 2 weeks. So, we're pretty flooded under. A lot of fun. Some snow as well?
Yeah, we have some snow here as well, close to where I live. Not exactly where I live, but in the region. But best of luck with the rain. For those new to the Micronaut podcast, we typically start the Micronaut podcast with an agenda. So let me get started. For agenda, I'm going to pass the baton actually to Graeme because he's always doing talks about Micronaut in the whole conference circuit. So what's coming from you, Graeme?
Well, coming from me specifically, I've recently, been doing talks on multi-cloud serverless with Micronaut and Graeme. So, in fact, I think a video of that talk was just posted. So, I think that's a really good, effective talk. Serverless is a big kind of use case for Micronaut. A lot of folks using Micronaut in serverless context. The conference season is just spinning up early next year again. So we'll see. Hopefully I get approved on a lot of talks, submitting a lot of things. So we'll see how it materializes next year.
We will include a link in the show notes to Graeme's talk about Micronaut and serverless. Serverless is one of these areas where typically Java was not a viable option. And with frameworks such as Micronaut, that's a big change for us because now you can write like your serverless code also with your main programming language. So that's really appealing for a lot of companies because, they don't have to have different teams. Can have the same team with a different knowledge transfer that can be applied there. We definitely have to talk about serverless in another podcast episode because it's a broad topic. But if you are interested, check out the talk in our YouTube channel. This podcast episode will be published Monday, the 6th of December, and we have Micronaut Live Tuesday, the 7th, and Thursday, the 9th of December. So we are doing Micronaut Live. We are streaming in twit.tv/MicronautFW. We are streaming live 1 hour Tuesday, 1 hour Thursday. I'm building a Micronaut application from scratch. I hope you enjoy the show and you join me either live or on demand in our YouTube channel. Also, we have scheduled a couple of training events for early January. We have building secure applications with the Micronaut framework training course, which is 3 hours a day, Monday, January the 10th until January the 13th. So that's 4 days, 3 hours a day. We are going to cover everything you need to know about Micronaut security. That's going to cover authentication, authorization, security configuration, JWT generation, remote JSON web key set, OAuth authorization flows, LDAP authentication, how to test the security in your application. So essentially, if you are interested in security and who is not, because you normally will have security in your applications, this may be a training course which will be of interest to you, and we'll include a link in the show notes. And the last bit in agenda is January the 15th, we have a workshop, a 3-hour workshop, what we call, actually it's January the 14th. We have a 3-hour workshop about testing. We call it Micronaut testing tips and tricks. I will cover things such as data validation, test-specific configuration, how to avoid bin pollution in your test, how to learn about Micronaut test, how to use test containers with Micronaut, how to test your serverless functions, how to work with the Micronaut HTTP client in your test, and essentially all the tips and tricks that I use daily to test Micronaut applications. So if you are interested, you can join both courses, the security and the testing tips and tricks, and have a full week of training, or just join the security, that's or the testing tips and tricks. That's up to you. I will click a link to both in the show notes, and I hope to see you in both. With that, let me go to Level Up. In Level Up is a section where we typically talk about tips and tricks in the framework. And today I'm going to talk with Graeme about Micronaut Data. And we are recording this episode the 29th of November, which is almost like a week after Micronaut 3.2 was released. And one of the features of Micronaut 3.2 is a new minor version of Micronaut Data. And that includes the support for repositories using the Criteria API. Can you explain more or less what that offers for people, Graeme?
Sure, yeah. So the Criteria API in JPA is, most folks are fairly familiar with it when using Hibernate. It basically lets you do dynamic queries, right? So up until now, Micronaut Data has been great for static queries where you know ahead of time what the query is going to be. So, for example, you type find by title or whatever, and that's going to execute a select star from book, where title equals. That's a kind of statically known query ahead of time. But if you need to build up a query from multiple different criterion, multiple different from based on user input, for example, dynamically, then you do need something like a Criteria API, unless you want to do manual SQL JPA QL string concatenation and munging, which is not really recommended and not a great experience, a bit of a security risk. So so we did have a good integration with other libraries that did this kind of thing. So we have great integration with Juke and JDBI, and of course, if you're using Hibernate with JPA, you could use the entity manage API directly. But with the latest version of Micronaut Data JDBC, we've actually partially implemented the JPA Criteria API on top of JDBC. So even if you're not using Hibernate, you can use that same API to build dynamic queries and execute them at runtime, which is a really nice feature, I think, and a lot of people will be appreciating that. It's been something that we've been asked for a long time.
Yeah, for many people, the way I like to think about this is if you are building the backend for the typical advanced search screen, where you have an input text field and then you have a bunch of radio buttons and checkbox, and when you receive that form submission, you need to create a query combining all these options which maybe are not present. That's when this Criteria API will become handy. So if you are using Micronaut Data JDBC, which we'll talk more about it now, please check it out, and I think you will find it a good addition to your Micronaut JDBC toolbelt. Let's go to the next section, Graeme. In the main section, I wanted to talk about Micronaut Data, but Graeme's history with Data Access Toolkit so this is not your first rodeo. So you have been really involved in persistence, right? For the past decade, I will say. What's the backstory of your story in relationship with persistence?
Yeah, well, so I think, Grails obviously has a long history with the kind of repository pattern and dynamic finders and so forth. I think Grails was pretty much the first framework on the JVM to bring Ruby on Rails active record pattern to the JVM, right? And it was something that attracted a lot of the developers to Grails, and specifically Gorm. Gorm was the persistence technology, and what we did there was, Hibernate was pretty much the standard with regards to persistence on the JVM. So we built a layer on top of Hibernate that let you persist and query for data in a kind of active record pattern. So you could do book.find by title and call a static method, and it would return, and completely dynamic in that everything was runtime based, right? So what the way it worked was it would basically intercept using Groovy's dynamic features, Groovy being a dynamic language, the find by title method at runtime, and translate that dynamically into a JPA or Hibernate query essentially at the time. And we built implementations of GORM or Grails on top of a lot of different databases, right? So we had GORM for Hibernate, GORM for Neo4j, for MongoDB, and very popular, probably the most popular feature in Grails, I guess, was the GORM, I would say.
Yeah, I would say so, yeah.
And and in the case of the MongoDB, we actually built like a completely clean room implementation of object to MongoDB mapping that integrated with the codec infrastructure of the MongoDB driver and so forth, so that we didn't have a dependency on anything else for that implementation. At the same time, around that time, I joined Spring Source, and the Spring team were interested in similar features for Spring, right? So I helped get Spring Data off the ground. A lot of my name is on a lot of the headers of the Spring Data code base as well. Because a lot of the Spring Data code base, the model part especially, is based on APIs that exist in GORM that we forked over and ported over. So you'll see a lot of similarities in things like the naming with persistent entity and persistent property, and in terms of how the model is represented. And obviously Spring Data has become really popular as well. But Spring Data works more or less the same as GORM in that it intercepts the query at runtime and translates it into the appropriate SQL. And at the same time, as Spring Data was evolving, we were starting to evolve GORM in a different direction, right? It started off being fully runtime, and gradually we started doing more and more and more at compilation time. So we added support for interface-based repositories that were completely compilation time-based, added more and more type checking, more and more static type checking, the where query DSL, which was type checked at compilation time. And so when we started Micronaut, I really didn't want to add the overhead of the runtime translation part into Micronaut, because it's you have to do more computation and so forth, and it's more expensive to do that computation and analysis at runtime. And with Micronaut being compiler based, we took a different approach, and with Micronaut Data of basically computing ahead of time during compilation the queries that you want to execute, right? So that's the major difference between Micronaut Data and GORM and Spring Data, is it'll do all the analysis and type checking at compilation time in a language neutral way, so it's not tied to Groovy like GORM was. It works with Java, it works with Kotlin. It'll do all the analysis and all the compute for the static queries that we know about at build time. It'll compute what query needs to be executed. And the advantage of doing it that way, the big advantage of doing that way, is that the runtime part of Micronaut Data is relatively small, right? Compared to, you don't need all this kind of heavyweight analysis stuff at runtime, because a lot of it can be done at build time, right? So we can do a lot of the computation and type checking and correctness checking during the compilation phase, and translate so when Micronaut Data compiles your app, it'll find a repository using the repository pattern, and it will see, hey, here's a method that says find by title. And it'll go, okay, that method says find by title. So what we're going to do is translate that method into a SQL or JPA-QL query at compilation time and store it. And then at runtime, the only thing Micronaut Data has to do is execute it.
If I am new to Micronaut, right, and you want to add persistence and you want to add Micronaut Data, so there is a couple of steps, right, that people will have to do. Like typically they will create entities, right? It will be classes annotated with, we have an annotation called at mapped entity, right?
Yeah, so it depends whether you're doing JPA or JDBC. If you're using JPA, then you're just using at table, the normal JPA entities, annotations. But we also support Micronaut Data JDBC, which is like without any object relational mapping layer. It's a simple data mapper.
We have to talk about the difference in detail about those, but so in terms, the user defines the entities either using JPA annotations or Micronaut Data annotations, and then when you say the repository access pattern, for anyone listening, that typically involves like you create an interface where you extend from, we supply a couple of parent interfaces. One is like called CRUD for create, read, update, delete repository, and we support like I think it's called generic repository, which is like bare bones. And you typically in that interface, it has two generics, right? One is the entity this repository is working with, and the other one is the primary key for the repository, right? And then you define methods in the repository, like Graeme was saying, like find by book by author and find by author, and you supply and microdata when basically, and you annotate the interface with at JDBC repository or with at repository, right?
Yeah, that's right. So that, if people are familiar with Spring Data, for example, or have used Spring Data before, the pattern is almost identical, obviously, because I was involved in how that was designed. So we're taking the same, and also we want to encourage people who already know Spring Data, to find it easy to switch over or learn Micronaut Data.
An easy learning curve.
So it's an easy learning curve. If you're familiar with Spring Data, then you can really easily get up to speed with Micronaut Data because it's more or less the same pattern that we designed in Spring Data. When I was involved in the project at the beginning.
So when Micronaut compiles your application, it will essentially see that you have these interfaces annotated with a JDBC repository, and it will generate the implementation of that repository, that interface for you, right? It will validate the parameters, and it essentially will warn you if you do a typo or anything like that because it has these conventions also, like if you do find by title, it expects that your entity has a title field, right?
Yeah, I mean, that's the big difference between Micronaut Data and GORM and Spring Data and so forth that makes it really cool is, if you type find by title and there's no title property on your entity that you're querying, whatever it may be, book or whatever, you'll get a compilation error, right? So in Spring Data and in GORM, those errors would manifest at runtime. This runtime exception. So I couldn't execute this query, because that doesn't compute basically. So we're able to type check a lot more effectively, and it works. It also works with projections. Yeah. So if you do a projection, you only want to select a subset of properties on a particular entity. So you have an entity that has 10 properties, and you only want to select 3 of them. If you supply 3 properties and one of them doesn't exist, the projection will fail to compile. And that's really cool because it catches a lot of developer errors early, and we're checking the syntax as you type, kind of thing, which is cool, and I think a big productivity boost.
Yeah, a projection is something that I really like, and I think it really encourages nice APIs because you can. How does it work? Essentially, you have to specify a DTO in. So if you have with the example that you were saying, you have an entity with multiple feeds. I always give the example, like you have like a book where you have like the description of the book, which probably you only want to show when you are like giving the full details of the book, but most of the time you just want to show like the book title and maybe the author. And you can just like create like a plain Java object, a DTO, with maybe the book name and the author, and do like a list book DTO and find, and Micronaut will essentially do the select title and author from book and instantiate the DTO for you and essentially like populate that class for you, right?
That's right. Yeah. Because I mean, ultimately, it's a massive anti-pattern if you're like sending your entire table across, as a JSON response. Typically, you never want to expose your like actual data model directly over REST like that. You always want to just. And the other thing about DTOs is you can combine them. So, for example, you can put like Jackson annotations or whatever on the properties of the DTO to modify the JSON to represent, because typically there's not necessarily a one-to-one relationship between the JSON response and the property names or table names in your database. So use a projection to select the subset and customize how the JSON is rendered, for example, if you're sending it over JSON or whatever, as a data transfer object, which is really nice, and it works really well, and it's type safe, and fails to compile if it doesn't work. And I think it's a really neat feature of Micronaut Data.
We have also now that we are talking about querying, it has also like a really nice feature which I like is often you need to send like getting back to the book example, if you are like creating an API where you are like exposing, I don't know, like allowing users to retrieve the list of books, you don't want to return like the 1,000 rows in the database. So typically you want to return like a page, so like, I don't know, like 10, 20 books, and give the user the ability like to know that there are more, right? So we have this, what's the name? It's a pageable interface. And if you specify that the pageable return type, what does it do? It does like a select, and it does also the count query, right? Or
it'll do both the count and the select at the same time. So again, if you're familiar with Spring Data, that's some there. It's allowing, and we have another parent interface called pageable repository where you can page data. And obviously, it'll do the kind of database specific. If you're using Micronaut Data JDBC, for example, it'll do the database specific. Each database has a different way to page data. Some of them support different mechanisms, and so forth. So that has to be like customized, and do that translation of providing the correct offset or etc. to page the data correctly.
We have support also for ordering as well out of the box. I think you can supply like, what's the name? It's a sort class, or even directly with the conventions, right? You can say like books ordered by title and things like that. That's
right. Yeah. So in the methods, you can order by multiple things as well. So you can, but you can say find by title, order by author, for example, and it'll order them by the kind of author property, and that works really, really well. But you can also supply that ordering by pageable and sort. So you directly on the method, if you want to customize ordering based on user input, you can supply that dynamically, and that also works, of course, with the new criteria queries as well. So you can customize ordering of the results based on user input.
One decision that people have to do is, so we supply is two flavors, right? We say that we supply Micronaut Data JPA and Micronaut Data JDBC. Can you elaborate which is the decision there, and in which scenarios would you recommend going in one direction, and in which scenarios would you recommend going in the other direction?
Yeah, so they're very different models, right? And so Micronaut Data JPA is based on JPA, clearly. And JPA is a full object relational mapping system, right? So So if you have a team that prefers to work, only in objects, and don't, maybe they're not familiar with the database or SQL or that, which a lot of JPA developers are not. They're used to working at the level of Java and rely on Hibernate to do the database heavy lifting for them. And of course, Hibernate has a lot of history of supporting different dialects and different lots of different databases, and in addition to that, it's a full ORM, which means it supports lazy loading, proxying, etc., etc. And whilst Micronaut Data JDBC is based on raw JDBC, and this is not really an object relational mapping system. It's more of a simple data mapper. It's for folks that are happy working with SQL and don't want their SQL hidden from them, and just want to translate their database results from their SQL queries into Java objects, but don't want to reason about things like dirty checking and lazy initialization exceptions and all those and obviously, in addition, it's much lighter weight, right? So Hibernate is still quite heavy. It's it adds massive weight to the application in terms of the size of Hibernate, and even with native image. So, and if you're writing a lot of microservices and serverless applications are fairly relatively simple and don't need a full object relational mapping system embedded into them, right? You can quite easily get away with a simpler model or a data mapper plus your own SQL queries and so forth. And the other thing that's important as well is that JPA encourages this model of having a single entity mapped to a single table, in that you have basically each entity maps to a single table in your whilst Micronaut Data JDBC is different. It's actually more we encourage, in fact, that you should have different entities per SQL result or SQL view or database view, or not just necessarily have a single table per entity. Because essentially you can have 3 different entities that map to the same table and have different subsets of data, for example, to customize different views or the database and so forth. And I'm really embracing SQL because SQL is great, right? And so SQL is very powerful, and a lot of developers don't like hiding it underneath JPA-QL and so forth, and do like working with raw, SQL result sets and all that has to offer. And finally, the other thing is with regard to native image. I did mention it before, but obviously Micronaut JDBC is much smaller, much more efficient, and is completely reflection free, and doesn't use runtime proxies or anything. So that produces a smaller native image. Developers don't have to reason about is Hibernate using reflection here or reflection there or reflection in the. I mean, Micronaut does deal with a lot of that for JPA as well, but it's still fundamentally using reflection underneath the covers, which adds overhead to your application and so forth.
Yeah, for me, Micronaut Data JDBC is the most exciting persistent story with Micronaut, and I personally am one of the developers who likes SQL, but I don't want to scare people because I think it's true that you can build really applications with because with the usage of JDBC repositories which are implemented for you, 99% of the time you are not writing SQL-like queries, right? You are writing just methods with naming conventions that get implemented for you. So I think for me, the great thing is that if you need to resort to a SQL-like query, you have it at your disposal, but you get the productivity gains of using repositories implemented for you
Yeah, exactly. People don't necessarily want to do the grunt work of the simple stuff, right? But they also don't want they also don't want the ability to use powerful SQL features, taken away from them. Now with JPA and Hibernate, you can use native queries as well. I'm not saying that, but it's so you can with Hibernate you can create a native SQL query and execute it and buy the results just the same. So it's not just about the SQL queries; it's also about just the runtime efficiency of how much smaller and more compact and it starts up instantly. There's no overhead, no reflection, and the other thing is Hibernate kind of comes along with a lot of kind of assumptions. With Hibernate you have a session which is stateful. Developers often get confused by the fact that if you read a lot of data and your session fills up, you get an out of memory error, or they get confused about how dirty checking works. Like, why is my there's a lot of like confusion. Whilst it's much simpler to reason about a simple data mapper where you just say insert this data or read this data, and there's no state, right? Micronaut Data is JDBC is completely stateless. Whilst kind of Hibernate comes with this notion of session and statefulness and so forth, and that adds a runtime overhead and a memory performance overhead to your application. But again, it depends on it depends on your use case. Like I said, a lot of teams are comfortable with JPA. They're comfortable with the overhead that it adds, and they're fine with it. But it's that flexibility of choice you get with Micronaut of I want to use raw JDBC or I want to use JPA, but I'm not tied to any single one. And of course, we have R2DBC as well.
Yeah, I wanted to talk about that. Just let me put a final pin on the JDBC discussion. So one of the things that you mentioned is like typically like Micronaut JDBC applications are more like performant because they have like a lighter runtime. I think that's particularly true for applications that are heavily read-intensive applications, more than write, which I think it's fair to say that most of our applications in general, where we need like the performance throughput is because we have like applications that do a lot of read from the application. And for that use case, if your application is like read-intensive, Micronaut JDBC is like a better fit, I think.
And in fact, Micronaut Data JDBC can actually be slower for write-heavy applications. One thing JPA does do a good job of is batching up a lot of like inserts and updates into one go and like sending them out. Now Micronaut Data JDBC does support batch, and we do allow you to do batch, where you can pass in a collection and batch insert a whole bunch of things, a bunch of records in one go. So it can be achieved. It just maybe requires a little bit more thought than with JPA, which is like synchronize everything when flushed, right? But having said that, for reads, it's like a 3x performance, for simple queries, because JPA has all of this translation layer where it has to like parse your HQL query and translate that into SQL, and then the unmarshalling and binding uses proxies, uses the session concept, uses reflection, the unmarshalling from the SQL to the result set to the object. So there's more overhead there. Micronaut Data JDBC for reads is significantly faster, no doubt, in our benchmarking.
Talk me now about the R2 DBC support. What's the story?
We have a third variety. Obviously, like I mentioned before, we have Micronaut Data JPA, we have Micronaut Data JDBC, but we also have Micronaut Data R2DBC, which is it uses the same plumbing as Micronaut Data JDBC, so it shares a lot of the code base, but instead it uses R2DBC, which is a reactive database access proposed specification for basically reactively accessing databases. And it has support for a number of different databases today. So there's support for things like Postgres, MySQL, etc. And Oracle have recently have released the first few versions of RTDBC support for Oracle to do reactive programming against Oracle database. So obviously, Micronaut's default server is based on Netty. So if you're using JDBC and JPA, you have to run all of the persistence logic on a separate I/O thread, because it's essentially using blocking communication with the database, right, for all those queries.
That typically involves adding a execute on to your controllers, or to blocking to your interfaces definitions.
Yeah, so you have to be careful. You can configure the whole server to offload every operation, or you can increase the size of the Netty event loop to run them all. There's various ways you can. But obviously, if you're, fundamentally it's using blocking I/O, which in the case of RTDBC, you can essentially run all your persistence operations on the Netty event loop and never block and scale to a higher number of threads and so forth. A high number of requests, connections, essentially. At the database level, non-blocking communication all the way down to the database level. So, you have to use the reactive programming model. So instead of CRUD repository, which we talked about before, where you have methods to perform CRUD, we have interfaces like reactive CRUD repository that return a publisher for every method, and we have sub-interfaces of those for RxJava and Reactor and so forth, where you can return a flux if you're a mono, if you're using Reactor for your result set, and transform those and so forth. So you can go fully reactive in your application code and not block, which is appealing for a lot of folks who want to achieve a certain level of scale.
So from a user perspective, it will be basically the change that they will have to do is they add a different dependency, right? Instead of adding Micronaut Data JDBC, they will add...
That's right. Micronaut Data R2DBC is the dependency. So you just add that.
Then instead of extending in their interfaces from a CRUD repository or generic repository, they will extend from reactive streams.
Reactive streams repository just returns publishers for every method. So, for example, the count method will return a publisher that emits a long number. And then there's sub-interfaces of that interface that return kind of reactive library specific types.
So if you are Project Reactor, a Flux, and if you are RxJava 3, like a single or
So if there's more than one result, if there's more than one result, you get a Flux. Or like the count method, where there's only one result, will return a mono of the number, right? A single result. Whilst find all will return a flux and you will be able to collect the result from the flux or do whatever you want. And if you're using RxJava, that'll be a flowable and a single, etc. for those different reactive types.
Yeah, that's exciting. And I see it's like an easy gotcha is to forget to handle that executons properly. So I think if you are using non-blocking APIs all the way, that seems to me easier to avoid making mistakes. Glance through it and we say that we support native images, but we support GraalVM native images for every variation of Micronaut Data, right? For JDBC, JPA, or R2DBC. So that shouldn't be a decision factor for users in which flavor of Micronaut Data they choose. We support GraalVM native image for all of them, right?
That's right, yeah. So native image support is added universally for all of those. So native image has an easier job to do with Micronaut Data, JDBC, and RTDBC because those two implementations use Micronaut's reflection-free bean introspection infrastructure. Micronaut Data JPA is using Hibernate underneath, and Hibernate relies on reflection. So Micronaut will register the reflection information for each entity that you use automatically. When you for JPA, but essentially, it ends up working, of course, because we register that configuration. But there's a little bit more overhead in terms of building a native image, the speed of it, and then obviously the size of the resulting image is bigger. But then again, that's a choice users can make, right? If they want JPA and they want the extra features that it offers, then that's the extra overhead is probably acceptable.
Do you want to? So one of the things that I have seen you talking lately about Java records and Micronaut Data. Do you want to tell people what's the story about Java records and what's the support of Java records in Micronaut Data?
Yeah, sure. So so first of all, Micronaut Data JPA is not a great fit for Java records because, like I said, it's stateful. So the whole JPA model is, based on statefulness and session, and that's why you have to, essentially, many features are not great for records. Like for example, the way lazy loading works with proxies. It has to essentially create a subtype, and obviously records are final, and there's a lot of set arithmetic in associations with Hibernate and JPA that is not appropriate for records. You can use records in JPA and Hibernate with DTO queries, I believe, but to model actual entities is not great. Now, Micronaut Data JPA on the other JDBC, on the other hand, and R2DBC, because they're simple data mappers and they don't have the same set arithmetic, and they're not. It's more every entity is essentially just a DTO. Then they're actually a great fit for records. So we have support for records for Micronaut Data JDBC and R2DBC. So you can define all of your mapped entities as records, and we automatically map. You can query and return records from repositories. But in addition to that, we have support for automatically returning a copy of a record. So, for example, if you save a record to the database, and the database ID is in the record, it will return a copy of it using a copy constructor pattern, and with the ID assigned, and it works really nicely with Micronaut Data JDBC. Now, obviously, JDBC doesn't have the same, like I mentioned, lazy loading and dirty checking and all those things that you would run into trouble with records using in those circumstances. So JDBC and RDBC are what we recommend if you're interested in using records.
Yeah, it's. I think it's really. I think it's really powerful. I think they're gonna get a lot of uptake. I think it's really simplify a lot Java development, because we often have this. Yeah, we often have the equivalent of our Java record with a lot of verbosity. So I think it's going to encourage a lot of immutable APIs, and I think Micronaut is going to be a perfect fit for people looking to use Java records already. And yeah, it's great. One thing that you mentioned is so what you mentioned there is if you have a record which one of the fields is the primary key, and that's auto-generated. What you say there with the copy constructor is you will supply that primary key as null when you save the record, and immediately, Micronaut, when it saves, auto-generates and inserts this thing, it will return you a copy of the record with the ID populated there, right?
That's correct. Yeah.
So that will be the pattern for users.
So that's how it works. And we have automatic in Micronaut's Bean Introspection API, which is part of core. We have support for creating copies of records already. There's a method, might be a nice tip for anybody who wants to use that. But basically, there's a method called with value. So you can get a Bean introspection, and you can say instantiate a new record, for example, and you can say introspection.with value and pass in the record, and it will and the property name, and it will return a new instance automatically for you if you need to do kind of dynamic record creation without using reflection.
Yeah, I have written it down for a future level up tip. I wasn't aware of that myself either. Do you want to mention anything else about Micronaut Data?
Yeah, no, just, I think there's a lot of exciting things coming up with Micronaut Data. I think there's still, a lot of innovation to happen in that area. So like we're working on, for example, document database support and so forth, which hopefully we'll get to release early next year. And it's been something that people have been asking for a long time. Like, can I use Micronaut Data with, all the different document databases out there? So that's going to be exciting. And of course, then there's graph databases. So there's, a lot of Micronaut Data, of course, is based on GORM originally, so in GORM had great support for graph database as well. So hopefully we get to reuse a lot of that functionality and introduce graph database pretty soon. There's still a lot of innovation to come with Micronaut Data, and folks should try it out and let us know what they think.
Yeah, that's exciting. We will come back to that when that happens. Let me thank our sponsors. This episode is possible thanks to the Micronaut Foundation's sponsors. We have two sponsors right now, Object Computer, which is our ambassador sponsor, and Safri.net, which is our bronze sponsor. We have also several individual sponsors, which I always make the effort of reading their names out loud, which is a bit cumbersome. So thanks to Corbinian Balch, Gis Loisnik, Lucas Morachev, Jen Weiss, Jeff Scott Brown, Danilo Marquez, Edgar Rios Navarro, Goran Erson, Andrew McKee, Balasum Brahmanian, Rengasamy, Philip Eisenbach, Hassam Mohudin, and Jason Siller. I think this list of names is the most difficult list of names I ever read out loud. Thanks to all of them. If you are interested in supporting Micronaut, supporting the Micronaut Foundation is a great way of doing that. Visit micronaut.io/foundation to learn more. And let me go to the content and guides section. I wanted to point two guides today, to highlight two guides. So guides are these step-by-step tutorials to create Micronaut applications. One is we just talk about Micronaut Data and Java Records. We have Micronaut Data and Java Records guides where we saw a couple of the patterns that Graeme just described. We saw Java Records being used for mapped entities. We saw Java Records being used for DTOs. We saw Java Records being used for configuration, for immutable configuration, which I think is a great use case as well. We saw Java Records being used for objects being serialized to JSON. And the cherry on top of the cake is that all of that works perfectly with GraalVM native image. You have instructions to generate the native image of the guide there. And the last thing that I wanted to point you to, and I will include links in the show note to both of them, is we have a Micronaut Data JDBC guide. Hopefully this episode piqued your interest about trying Micronaut Data JDBC. So I will point you to a guide that we have to do that. I think it's time to wrap it up, Graeme. It's already 50 minutes recording. Thanks for joining me today. Do you want to tell our listeners anything else before we wrap it up?
No, I hope they enjoy the guides and let us know feedback about Micronaut Data and anything we can improve. Love to hear it.
Yeah, absolutely. Feedback is, we have said through the episode, but we have a lot of community feedback and community contributions, and that's, I think, part of the success of Micronaut. So keep those coming, and we see each other in 2 weeks. Thanks, everyone.
Bye.